Okay, we're going to talk a little bit about powers and roots. So a number raised to the nth power is a number, that number multiplied by itself n times. And n is called the exponent, okay? So for example, if you have 2 raised to the first power, that just equals 2 because it's 2 one time. If you have 2 squared, well that's 2 times 2, which is 2 raised to the fourth power. So squared means 2 times itself twice. 2 cubed means 2 multiplied by itself 3 times, which is 2 times 2 times 2, which gives us 8. Now, any number raised to the 0 power is always defined to be 1. So that's very important. Anything raised to the 0 power, always 1. Okay? So for example, 2 to the 0 power is 1. What about 7 raised to the 0 power? That's 1. 11 raised to the 0 power. You guessed it. 1. What about 1,271 raised to the 0 power? Yep, you guessed it. 1. Anything. 7 million to the 0 power. That's 1. Okay. Negative powers are called reciprocals of the corresponding positive power. Okay? So when you hear the word reciprocal, this is what I want you to think. Kind of easier. I want you to think flip. Change the sign on the exponent. Okay, the exponent is this little number. I don't know if I made that clear, but the exponent is the same thing as the power, okay? That's the exponent. So let's look at this one. We have 5 raised to the negative 2. So this is always, you could write any whole number over 1, okay? So when I say flip, it's exactly what I mean. I want you to put the 1 on top and the 5 on bottom, and then we're going to change the sign on the exponent. So this sign is a negative 2. It now becomes a positive 2, okay? So we're just going to flip it, change that sign. And then we know that 5 squared is 25. So the answer to 5 raised to the negative 2 power is 1 over 25. Okay? So now let's look at this one. If we have 2 raised to the negative 3, well, we know 2 is a whole number, right? So we could write that over 1. Now we're going to, so that becomes 1 over 2. Change the sign, went from negative 3 to positive 3. Now, if we look up here, we know 2 cubed is 8, so then that becomes 1 over 8. Okay? A couple more. So if we have 3 to the negative 1. No, that's written over 1, so we automatically put 1 on top. And we're going to change this sign, so that's going to be 3 to the 1 power on bottom. Was a negative 1, becomes a positive 1. And anything to the first power, it's always itself. So it's going to be 1/3. Okay? Next one. What if we had 7 to the negative 2 power? We're going to think flip. So we're automatically going to put the 7 on bottom, and then we're going to change the sign. So from negative 2 to positive 2. 7 times 7 is 49. Because 7 squared, you know, squared means anything times itself, so 7 times 7. Okay? Right on. So let's talk about the power rules. The following rules: x represents a number being raised to a power, and n and m are exponents, okay? Note that these rules work only when all powers apply to the same number, a. Okay. It's just a lot of math speak. So to multiply powers of the same number, add the exponent. So we're multiplying our same base. This guy's called a base, right? So we have a times a, but they have different powers. When you multiply the same bases, you add the exponents. So you could just write a one time and then say n plus m. That's multiplication. That's the power rule. The multiplication. So here we go. Let's say 2 cubed plus 2 squared. We have the same base, which is 2, so we only have to write 2 one time. And now we're going to add the exponents because I did something wrong. These are multiplied. My bad. I was thinking about adding. These are multiplied. Okay, so now we're going to add the exponents. So that's going to be 3 plus 2. So this is going to be 2 to what power? The 5th power. And you can put that in your calculator. Turn my calculator back on. And if you take 2 raised to the 5th power, then that's going to give you 32. There went that pencil. Okay, now we're going to divide powers of the same number. That means that you subtract the exponents. So here we have a to the n divided by a to the m. So we could just write a one time, and we always subtract the bottom from the top. Okay? So let's make our problem be 5 cubed divided by 5 squared. So we have the same base of 5. We're going to subtract 2 from 3. Okay? So that's going to be 5 raised to the first power. You know, anything raised to the first power, always itself. Right on. Now, when we have a base raised to a power and then to another power. Let's look at this one. Then you multiply the two powers together, okay? Say we have 2 squared, and then that's all cubed. So we only have one base this time, right? Where here we had 2. That's the difference. So we have one base, and this is going to be 2 times 3. And that's going to be 2 to the 6th power, and 2 to the 6th power is 64. So that's the difference here. This was 2 bases multiplied, 2 of the same bases multiplied. So then you add these powers. This is one base multiplied to 2 different powers. So just to make that very clear, it's kind of confusing whenever I was in my beginning math classes, so I want to be very clear on that for you guys. Okay. Now, basic roots. Finding the root is opposite of squaring a number. So a minute ago we talked about like 2 squared was 2 times 2, right? So now we're going to talk about roots. So the second root, or the square root, are given with the number under this symbol, okay? More generally, we indicate the nth root by writing the number under this symbol. So anything larger than a square root, we could just put that number in place of this n. Mathematicians on the regular are very lazy, so with the square root, we just leave it. Nothing written here, it's just implied that there's a 2, okay? So if you see this symbol and there's nothing written here, know that it's a square root or a second root, okay? Because we're just lazy. I'll say that over and over again because I fit that stereotype. I mean, I'm not lazy, but like, I'm not going to write something I don't have to. Okay, so the square root of 4 is 2. Because 2 squared equals 2 times 2, and that equals 4, right? So, kind of, it's just working backwards. So the cubed root of 27 is 3. And that's because 3 cubed means 3 times 3 times 3 is 27. So if you ask what number you took 3 times to get 27, well, that was 3, and you see that here. The fourth root of 16 is 2. Same reasoning, because 2 raised to the fourth power, well, that is 2 times 2 times 2 times 2, which equals 16. So what this means is, what number did you use 4 of to make 16? When we step over here and we see we took 4 2s to make 16, right? Here again, what number did you use 6 of to make a million? Well, that was 10, because 6 to the 10th power is a million. Okay? That's kind of what that means. When you see this sign, this just means, what number did you take 2 of to make whatever's underneath it? All right, I hope I explained that pretty well. If not, I'm sorry. It's kind of the best explanation I could give today of that. Maybe tomorrow, if you call me, I could do better. But that was today's best explanation. Okay, so roots and fractional powers. So the nth root of a number is the same as that number raised to 1 over n power. This is pretty cool, I think. I don't know. I hope you think it's cool. Bad thing about taking my classes, whatever, I think it's cool. You guys have to see, so sorry for that. Okay, so if we have, all right, colors out here. If we have x raised to the 1 over n power, that is the exact same thing, right, as the nth. I'm going to show you how. It's pretty neat. Like I said, I think it's neat. So this is your power. Right here, there's always, remember, any number raised to the 1 power, right, power of 1, is always itself. So the fact that this is just an x means that there is a little implied 1 right here. Remember, mathematicians are lazy. So if we don't have to write it, we don't. But this 1 is also our power. Okay, now, this guy is our root. And remember, this is the nth root. So he is also our root. So it's just a different way of writing it. We take this from here and we put it on top of our square, put it outside of our square root, okay? Or our nth root. So I have a way, I'm just going to tell you right now, I remember things in random, silly, weird, strange, I don't know, whatever, put whatever word you want in there. I won't be offended. Ways of remembering things. So I've had a professor in my past that drew a picture that helped me remember the difference in a power and a root and where they go in this fraction. That helped me remember it throughout my whole math career. I never had to put much thought into it after I saw the picture. So I'm going to draw the same picture for you. If it helps, great. If it doesn't, well, this may have been the most expensive artwork you've purchased until date, okay? So here we go. Here's a tree. It's a freaking big tree. I didn't mean to draw it that big. Okay, so here's our tree. I'm not going to make it go up into the picture. Here's our tree. And here's the tree roots, okay? And just like, I need to pull this down a little bit. Just like up here, the root is at the bottom. You will notice that in the real world, name of our course, the roots are at the bottom of the tree. Okay? So the roots are at the bottom, just like in your radical, fractional, let me just say that. In your fractional side over here, the root's at the bottom. Can't think of the right word right now. All right. Now, also, here, we have this over here. Man, I do this right in the middle. which is our power lines in the real world, right? I'm going to go ahead and draw it across. Sorry, y'all. This is our power line, and the power is on top. Just like over here, our power is on top. So our roots are always on the bottom, our power is always on the top, and it's the same way over here with our fractional side. Our power is always going to be on top, and our root's always going to be on bottom. So here's our picture for that. Sorry, I drove on your problem. We're going to work them anyway. So that's how I always remembered when I got to my fraction, going from my radical to my rational, that's what I meant to say a minute ago. I always knew my power was on top and my root was on the bottom, and I never had to think about it because of my tree and my power line picture that they drew. So there you go. Hope that helps. If not, like I said, it's probably the most expensive picture you've ever paid for because, you know, tuition's not cheap. So anyway, there you go. So now let's look at this one for our example that I just drew all over, which is only I would probably do that, but that's great. So we have 64 raised to the 1/3 power. So our root goes to the outside, right? And our power is on the inside. And then what number do we take 3 of to get 64? Well, that's 4. Here we have our rational. We have 6 on the bottom, so he's the root. He goes on the outside, right? Because it's a 6th root of 1 million, and then it's raised to the 1st power. And how do I know this is 10? Well, 1, 2, 3, 4, 5, 6, so that would be 10 raised to the 6th power. It's a trick you can do. Pretty cool. Okay. Or you can just put in your calculator. That's another trick you can do. Okay. Rules of algebra. I'm going over this because you need to use this in some of your homeworks, so this is here for that. Major goal of algebra is to solve equations for some variable. This is where everybody gets tricked up. Everybody's really good with math until it comes to, oh my gosh, we throw an X or a Y in, right? And then everybody like loses their mind. So we're going to do this and hopefully make it not so scary. A variable is just a placeholder for a number. It's just, you know, like when we were in lower levels of math, we would say, you know, 3 plus 4 equals blank. Well, we know it's 7, but we didn't know what that blank was. So now we just like put in a X or a Y. So that's what we're doing now. Same kind of thing, a little more complicated, but kind of the same concept. So a variable is just a placeholder, right? So it's just put in there until we figure out what number goes there. So that's all it is. So here's some basic rules that we're going to use for this homework that will help it be easier for you. So we can interchange left side and right side of an equation. Okay, that's legal. You can swap them. I like swap better than interchange, but use whatever word you prefer. So if you have X equals Y, same thing if you rewrite it as Y equals X. Okay, perfectly legal. You can add and subtract the same quantity on both sides of the equation. So what you do to one side, you have to do to the other, okay? You can't play favorites. Like you can't add 3 to one side and add nothing to the other. If you add 3 to the left side, you have to add 3 to the right-hand side. Like it's like having kids, you know, you can't play favorites. So that's the other one. You can add the same or subtract the same quantity to both sides. You can multiply or divide both sides of the equation by the same quantity as long as you do not multiply or divide by 0. Okay? No 0, because then that makes everything 0, and that's no fun. Like, there'd be no math involved in that, and that's cheating. We don't like that. We want to do some math. And then number 4, you can raise both sides of an equation to the same power or take the same root of both sides. which is the equivalent of raising both sides to the same fractional power, okay? But once again, no favorites. What you do to one side, you got to do to the other, okay? I say that so many times. My college algebra class is sick of me saying it. Like, they hurry up and finish it so I don't say it. Okay. So let's look at this one. We're going to solve. This is using example 1, okay? So we can interchange. So solve the following equation. Qx minus 17 equals p plus 4q minus 2. And we're going to solve for p. That means we want just p on one side and all the other stuff on the other, okay? So we have p here, right? But we have a bunch of other stuff over here. So we want it to where we just have p over here. So let's start moving all this stuff to this side, okay? That's all we're going to do. So we're going to leave p alone and move this stuff over. Let's do it one at a time. Start with this guy. So we're going to move 4q over. It's a plus 4q, so to move him, we're going to subtract him, right? Because since he's plus, we want to subtract 4q. We're going to write him strategically so he lines up with the other q's so we can see what we're subtracting him from. We don't want to write him like over here because then that's kind of willy-nilly and it's hard to see. So we want to line them up like in columns, okay? So plus 4q minus 4q, well, that gives you a 0, so let's just cancel him out. He's gone. Cool? So if we have 8q and we subtract 4q, if you have 8, take away 4, well, we're going to have 4q's left. This guy, we didn't do anything to, so we have to bring him down. We didn't do anything to p, right? So we're going to bring p down. This guy's a 0, so we don't have to write anything there. And then we can bring down this 2. Y'all cool with that? Right on. Okay, we're close, but we're not there. We just want p on this side, right? We just want LHS, left-hand side. Y'all cool with that? Oh, that's right. I don't know my left and my right. Right. Sorry. I do know them. I'm just sometimes goofy. Okay, so if we want to move this 2 over here, what will we do? It's a negative 2, so we're going to, you got it, add 2. If we add 2 to one side, we have to, yep. So y'all are already doing it too because y'all sick of listening to me. Okay. These two are going to cancel. That's going to leave what on this side? Yes. So we're going to have 4q negative 17 plus 2. Negative 15, yo. Okay. So we have 4q minus 15 equals p. I don't know about you. That still looks wonky to me because this said to solve for p. So I want mine to be written like this. P equals 4q minus 15. Remember what it says? If x equals y, then y could equal x. So if this is true, this is also true. So we're happy. Okay? You just did algebra. Right on. Okay. Let's do an example of rule 2. Okay. So, I need to look at my rules, huh? Oh, what you do to one side, you got to do the other. I'm just going to do this without that. I'm not even going to put it back over. Okay. So we want to solve for x. So once again, we want x left hand side. Got it right there. Okay, so we have x and minus 3 equals 9. But we just want x over here. So what are we going to do? We're going to move 3 over. So we add 3 on this side. Can't play favorites. What you do to the left-hand side, you got to do the right-hand side. These cancel. So x equals 12. Cool? We could check this. Let's do that. That would be fun. So let's plug this 12 in place of this x. So if we said 12 minus 3 equals 9. Was that true? So 9 equals 9. Check. Awesome. Okay. Here, this one says we can multiply or divide as long as we do both sides by the same number. Let's do it. We're solving for x again, so we want x alone. All right, so it's already over here, so let's get him by himself. Let's talk about this for a minute. 4 equals 24. So this implies that this is a multiplication, right? Because that means 4 times x. So what undoes multiplication? Like, what's his arch nemesis, I guess? It would be division, right? So if this is multiplication, then we can divide. We divide by 4 on this side, we have to do it on the other. You're so right. These will cancel. X equals 6. So if it's addition or subtraction, you just do the opposite sign. If it's multiplication or division, you just do the opposite sign. Cool? So this one we're going to solve for x. Okay? We have it y equals. This time we want to solve for x. So we're going to have to move everything over. We want x. Okay, we have y alone. That's not what we want. We want x alone. So just like before, we're going to slowly move them over. But you have to move the man who stands alone. That's what I call him. And he's the guy who's separated by a plus or minus. He has to move first, okay? So let's do that. Let's subtract 9. What you do on one side, yep, you do to the other. This is going to cancel. So then we're going to have y minus 9 equals 3x. Awesome. So now we just talked about this, right? We have 3 times x equals y minus 9. We want the x alone, so how would we get x by himself? This is multiplication. You want to do multiplication by, yep, division. This cancels, so we're left with x equals y minus 9 over 3. Now remember, here, you cannot divide anything because this has a subtraction sign in the middle, right? So we're done, except for, I'm weird like this. This looks a little wonky to me, so I'm going to rewrite it and say x equals y minus 9 over 3. And that would be my answer. Okay? Let's go back up and look at these. I could check this one. I could say 4 times 6. Anytime you plug something in for x, technically you should put it in a parenthesis. I didn't up there, so my bad. And that should equal 24. Well, 6 times 4, 24 equals 24. Tick. Okay? And we can check this one too. This will be really fun. So we have this x, and we're going to plug it in place of this. Start looking so. So if we say y equals 3 times y minus 9 all over 3 plus 9, looky here, we can cancel, we can cancel the 3's to start with, right? So this is going to leave us y minus 9 plus 9. Well, this is going to be 0, right? So this equals y. So y equals y, and that's a true story. So that one's correct too. Okay. So this one says to find the positive solution of the equation x raised to the 4th power equals 16. So to do this, remember we could write it different ways, but let's take, to get rid of a 4th power, we could always take the fourth root. So I'm going to write x to the fourth equals 16. So to undo this fourth, you can do a fourth root, okay? Because they cancel each other. But what you do on one side, what has to happen on the other side? Fourth root. Now with even roots, you always have to do plus minus. So now this is, since those canceled, this is going to be x equals plus minus 2. And the reason for that being the plus minus is because you can plug in a -2 or a +2, and it's going to come out to be 16. So it wants the positive solution. So the positive solution is going to be x equals 2. And I'll show you. If you take -2 times -2 times -2 times -2, right? These two are going to give you 4, and these two are going to give you 4. And if you multiply those together, then that's going to give you 16. So you took 4 -2's and it gave you 16, which would mean that that would be -2 to the 4th power gives you 16. So that's why you always have to do plus minus with an even power, because that's always the case, okay? All right. You have the best day.